All right, guys, it is now day 2, and you have came back into the lab, and you are ready to finish this experiment up. But before you can do that, you got to actually run your samples. So I hope that on this day, you've brought your samples in. You're ready to analyze them. You're ready to know more information about the total organic carbon. And once more, if you've been paying attention in the lecture videos, the TOC is actually not total organic carbon. That is a lie. And that's because we focus on MPOC instead. And the NP is non-purgeable. That is what this is after. So anything that can be purged out of the sample is going to go away through the bubbling of 1.5 minutes into the process of the sample processing and technique that we're doing. So all of the volatile organic compounds are going to go away. The MPOC is what we left over with, and the MPOC is often regarded as the total organic carbon. That is really what we often refer to it as on reports and the various other types of things that I am doing with this particular type of test. And most people know that, all right? So what's going on here is that on day 2, everything's ready. Everything needs to be placed into a batch, organized, and we need to get this machine up and running. So it looks like there's a couple of things that we need to make sure of. We have all this little checklist. We're ready to go. I think we've made all of that. We've organized it. And on this very first page, we're going to see a suggested order of how to run these samples. It looks like we're going to start off with our blanks. And then after a couple of blanks, just to make sure the system's flushed out and ready to go, then we're going to make our calibration curve. One of the very first things that we do when we run samples and when we run standards and when we get these machines up and going. So we're going to make our alcals according to the directions. We're going to make a total of 5. Then we are going to run some of our quality checks. We talked about what those are going to be. We're going to run another blank. Clean it all out. Then we start running our samples in duplicate. And we really like to put blanks in between each and every one. And then 17 says additional samples as needed. So depending on how many you brought in, what should we be doing? Dupe, 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 dupe. But keep in mind, every 10 samples that you bring in, duplicates are included. Every 10 samples that you run, you need to analyze another CCV, a continuing calibration check throughout that process. Once all the samples have been went through, all of them are kind of found their home, found their spot. We're going to analyze them. On the back end of the batch, we're going to be running our spot verification, our QC sample, our QC dupe that we had to do, our last continuing calibration verification, which is really the end one here, and then our LRB, which is another blank. We like to keep these systems clean because dirtiness and contamination is often an issue with TOC instrumentation. All right, so that's the game plan. That's how we're going to order these up in the batch trays. That's how we're going to fill out our batch tables so we can let the machine know what it needs to do and how it needs to run it. That instrument has to have all that information from you. 7.3, standard solutions for the calibration. This paragraph is basically saying, listen, you made close to a 50 ppm, and we're going to place that in the auto sampler tray of the instrument. And we are going to tell the machine to make a 25, a 10, a 5, a 2, and a 1 as far as the calibration standards that we need at this point. If my machine could not do this for me, then I would be required to do this by hand. But our instruments can, so we're going to take advantage of it. So that will save you a little bit of work, save some sample prep time. We've did enough diluting, pipetting with all the other stuff. As before, comments, name, date, time. Supervisor looks over it, making sure that everything's okay. Next up is the analysis. Once everything gets ran, I got numbers. We need to figure out, do these numbers make sense? All right, so for the first one, we're going to look at our calibration curve. This should be a straight line. It says that this should be done daily. Our criteria is 0.995 or greater. How did you name the calibration curve? So that way someone can find it in the system if they have to refer to it. What is the R squared value on the curve? We'll show you how to find that information once it gets generated. Did you print it? Yes or no? Did it pass? Yes or no? Did you have to repeat the calibration curve? Yes or no? And if this fails, you can't do anything else. You got to get a good calibration curve before you move further. So that means all the work that you did with your batches, loading, running, all of that is for nothing because you did not have an acceptable calibration curve. Again, write comments. What could have went wrong? What observations did you see? Name, date, time. A supervisor will sign once they make sure that data is legit. Next is the initial calibration verification. I'm going to run it. I'm going to get a number. What is the actual concentration of ICV? This is what it should have been. Based on my calculation, that is what it should have been. What is the reported concentration? This is actually the number that shows up in the data report once it gets finished and once we print it off. Did you print off the reports? Yes or no? What is the difference between those two values? So that is just the subtraction, folks. That's all that is. So for instance, if this is 6.2 and I should have a 6.3, I'm going to take the difference, and that difference is a 0.1. So we're going to subtract. That's what we're doing. We need to calculate the error of the difference. So we're going to take that difference, whatever number you got from up above. We're going to divide by the actual concentration times 100. And that will give me a percentage. Hopefully that percentage passes within plus or minus 10%. Did it? Did it pass? Did it fail? Did you have to repeat an ICV because you had problems with it? Yes or no? Make notes, write comments, sign, date, time it. Let a supervisor see your data. Let them sign off on it. That sheet is now finished. Next up is the continuing calibration verification. And notice it says -1. This is the first one that you run. Again, you've calculated the actual concentration. You know what that should be. So this is based on your calculations. What is the reported number? That's on the data report. Again, did you print data off? Proof in the pudding? You putting your mouth where your money's at? Money where your mouth's at. I don't think it really matters. Next, just as before, you take the difference between these two numbers. That goes here. Calculate the error, which is take that difference, divide it by the actual value. Ding, 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 actual times 100. And did it fit within plus or minus 10%? Did you have to repeat it? Why do you think that repeat had to happen? What could have went wrong? Write down your comments, sign, date it, have a supervisor review it, look at your numbers, make sure everything looks legit, let them sign off, and away you go. This form is going to have to be repeated, though, and you're going to see that in the document because there is probably a end one that you are doing that's like the ECV in a way. There is a chance that you have more than 10 samples, so you're going to be running another continuing calibration check in the middle of a sample batch. So there could be a second one, there could be a third one, there could be a fourth one, depending on what we are doing in the lab setting as far as batches are concerned. You could have more than one of these forms. Each one should be unique to that calibration standard that was ran. So you are going to be running them 3 or 4 times. You've made 3 or 4 sample containers for that reason. That's not a big deal. You just got to make sure that these forms are well documented so we know which form goes to which sample. And that is why up here at the very top it says CCV-1. All right. Next up is the lab blank. The lab blank is just going to be deionized water, distilled water preferably. It's probably not going to read 0 part per million though, but we need to run it. We need to report it. We need to see what's there. So it looks like we got to do this every day, of course. Immediately after the continuing calibration verification, after every 10 samples, we should be running a blank. And these are the minimum requirements. What you're going to actually find is that we're running blanks actually in between all the samples. But the formal lab blank is going to be prior to the analysis. That is what this form is going to refer to. You're going to have tons of blanks throughout your sample batches. That's fine. But this is going to be prior to any analysis at all. So that very first blank before you started running actual stuff. So what is the reported number that's on the data sheet? Is it less than 0.5? Yes or no? Did it pass? Does it have to be repeated? And quite honestly, folks, if it's got to be repeated, there's nothing that you can really do here because it is a blank and it's just simply water. What you could do is just rinse out the container extremely well, fill it full of water again, put a lid on it, and rerun it. There is a chance that contamination got inside of your container. It shouldn't have been there. They should be clean, unused containers. But, I mean, you know, shoulda, woulda, coulda. So if that is a problem or if that's an issue, then that's one of the ways that we can fix it. To be honest with you, if this blank is greater than 0.5, then I'm going to be okay with that most of the time. I'm just going to say, let's deal with it. Let's go with the flow. Again, nothing formally that we can do necessarily to improve that other than running distilled water. If we run distilled water, then all of this mess goes away. All right. But we've got deionized water in our system. Until we get our ultra purified water up and running, we're running distilled or deionized water. Next up are the samples, and the samples are just, listen, everything was ran in duplicate. So here's a form for you to log that information in. So what is the number for the first round of sample number 1? What's the second round of sample number 1? So these are the duplicates, and that's where you're going to write that information. Notice it only gives you room for 3 of these, sample 1, sample 2, sample 3, and so forth. If you need more data, and you probably will, you need to print off another report. We're going to change these to 4 and 5 and 6 and 7 and 8 and 9 and 10 and 11 and 12. We might have those forms ready to go if that's what you need. But however way that you play this is going to be a minimum of 3 samples that you're going to be running no matter what. All right, so let's pretend like everyone in your group, oh no, I forgot to bring samples in. I'm so sorry. That means I don't have to do work. No, we're going to run at least 3, and we've got 3 that are ready to go, and we've got 3 that you're going to be running no matter what goes on. So that is the intention of this form. If your group brought in more than 3, we'll have some extra forms that you can print off and fill out the necessary information with. Down here at the very bottom, it did tell me to calculate the average and standard deviations and confidence intervals of these types of samples as I begin to process them. Again, we're doing them more than one time. We want a representative average and standard deviation. So how accurate and precise are these numbers going to be? That is what we're after here in this particular table. So if you did bring in a 4, a 5, a 6, 7, and 8, that table needs to expand, and you will have that row for every single sample that you have brought in. Next up is the spiked verification. So again, another form, another check. We want to make sure that this looks okay. What was the concentration of the original sample? Well, you need the data table in order to determine that. You know which number of sample that you spiked, and whatever that concentration is, that's the number that goes here. So we picked sample number 5, and we spiked sample number 5. So what is the average concentration of standard number 5 or sample number 5. That's the number that's going to go into that blank. The added concentration, if you followed the directions, this is going to be a 1 ppm that's there. Based on the amount that we added, that 1 milliliter of a 50 ppm into a 50 milliliter volumetric flask, it is going to be a 50 ppm addition. The expected cumulative average, or the total here for TOC, is your original and your added amount. So that means whatever number this is and whatever number this is, you're going to add them together and you're going to get a total. And that total is what we should be expecting on the report for the spot data point. Next up is the reported concentration of SV. Again, this is from the data sheet. So whatever value is going to go here, it'll say spiked. This is what you got. Did you print that report? Yes or no? What is the difference between your expected and your reported concentrations? So that is what we got on our data report to what we expect. What is the difference between those two values, A and B? That's the number that goes in for the difference. Next line item is the percent error. So that is the difference divided by your expected concentration. This is what it should have been times 100, just as before in all the other sheets. Did the sample pass? In other words, did you fit within a 10% window? Yes or no? Did it have to be repeated? Yes or no? Write comments, sign, date, let someone review it, let them sign it, and you're off to the next. Next up focuses on the quality control. This is the sample that the lab has made, that the lab has given your group to analyze and run. We are not running QCs every 10 samples. We run them at the end. That's just how we change and modify this a little bit to save some time. So this is going to refer to the one and only QC that you have ran. That QC, though, was a duplicate. So we're talking about averages here. So the actual concentration of the QC, this is what we know. And we will tell you what that number is at the end of this, not in the beginning. The reported concentration, notice it says average. We're going to run that QC in a duplicate. We're going to take the average of those values, and that is the number that goes here. Print off the reports, yes or no. What's the difference between these two values? That's that calculation. Just as before, calculate the percent error. So take the difference between those two values, divide by the actual concentration, which is what we know, this is what it should have been, times by 100. And hopefully that is plus or minus 10% for an error, or lower. We don't want it higher than 10%. Did the QC pass? Yes or no? As before, write any comments, statements that you want to include. Sign, date it, time it. Let someone look over it, making sure you did the calculations the right way. And then that now is complete. This is a form for the continuing calibration verification. We've already talked about this. I'm not going to talk about it again. This is an identical replica of CCV-1 because you could run a second, you could run a third, you could run a fourth, you could run a fifth. Remember, I told you, listen, there's more forms. Fill out a form for every single one that you do. We want to make sure that these are passing along the batch as it gets processed. So we've got to check each and every one of them. And ECV also is your last CCV. Nothing special, nothing new. Data sheet's going to end up with something like a summary table. The first column is going to be the concentration that has been reported. So whatever shows up on the data sheet, I'm going to write that down into an actual document. It seems redundant, but it's not. Writing it on paper with pen and paper is great. Printing it off, absolutely, that's backup. Saving in electronic form, wonderful. We'll add that to the mix. We do all of the above. The actual concentrations of what these things should have be, you know what the majority of these are going to be. Notice it says NA. You don't really know what our blanks are going to be reading. You don't know what your samples are going to be reading. Notice it continues on with additional samples. If that's how many you brought in, that's great. You've got spots for these in the summary table. And then you know what the concentrations of the spiked ones should have been and the quality control and your ending CCV. So these are not NAs, but everything else is in the middle. Unless they're CCVs. Percent errors are just coming from that form. All of those forms that you filled out, you've calculated the errors. We're just asking you to write it down again in a summary table for a very quick reference, so that way we don't have to suffer through 50 different pages of a document. So just put them on the summary table. It's just transfer them over. That's all you got to do. No additional calculations are right there. And then up here it says pass. Does it pass? Yes or no? So pass, yep, no, yep, no, yep, no. I can't really pass or fail samples. That doesn't make any sense. Like, samples are samples. They are what they are. They're going to read what they're going to read. So all of those are going to be in A's. Oh, look, there's a CCV. I need to see if that passes or fails. And then more samples are going to come. And then now I'm kind of done. Did my spiked verification pass? Did my QC pass? Did my last continuing calibration verification pass? Yes or no? That's what that is. Again, a summary table is meant to just put all of the information in one spot, so that way it is a quick reference versus 25 or 30 pages of documentation that I have to suffer through. Finally, at the very end, you're going to put the names of the people in your group. You're going to sign it. You're going to date it. And then someone's going to look at it and someone else is going to sign off on it, making sure, yeah, this looks legit. And folks, you've just now completed your very first quality control batch. A lot of people, again, if they graduate with a bachelor's degree, a master's degree, a PhD maybe, even some of the other associates programs, they have never been experienced to the concept of what a batch of samples is all about. They have no clue that all of these self-check measures have to be in place before we can release data. And that is the purpose of our CTC 115. It's one of the purposes of our CTC 115. What is a batch? And I think that after you complete this exercise, you have a much better understanding of what a batch is compared to someone else that's maybe never had to ever go through this type of process before. Even though this is real life, even though this is real work, well, you're going to be work ready. You're not going to be textbook ready. You're not going to be theory ready. I mean, you probably are. I hope that you are. But what we do in here is not a textbook. What we do in here is not let's read and memorize and regurgitate information back onto a sheet of paper. We want you to be exposed to real things that go off in real work environments, and a proper batch of samples is one of those. We are using method 415 as an example. It's one of the easier ones. There's not a lot of tricks and stuff that go on into this, and I think it opens up the gate here to the world of quality a little bit better for you versus some of the more complicated methods that we might see later on in the program when we get to that point. All right, so with that said, good luck in the lab. I mean, you're working as a group. I hope you get along with your lab partners. If you don't, let me know, because I want to be there and I want to laugh about it. And then, if you've got questions, if you've got issues, let me know. On the second day, we're going to go in, we're going to show you how to input the samples, and I'll show you some basics of the instrument, so that way you kind of know how to get this thing started up, how you can get this stuff to do what you need done, and we'll go through that motion. It's not the only time that we're going to be using a TOC, but it is your first introduction so far if you've taken 114 and or 115 and 150. So no matter who you are, this is the first time that you're going to see this kind of in action. So with that said, see you then, and we'll talk about stuff a little bit later on. Bye.